Hello, today we're going to be talking about the complex number system. Everything pretty much up to today, and what you do mostly on a daily basis is work with the real number system. Anything that basically can be placed on a number line, so decimals, fractions, whatever the case may be, positives, negatives. Now, complex numbers system is a larger system that allows you to work with square roots of negatives. So anything can be written as a complex number in the form a plus bi, where a and b are both just real numbers. Basically, we're dealing with some coefficients, and then I is defined as square root of -1. So here I have some basic examples. The number 7, for example, can be written as 7 plus 0i. Number 2, square root of -4, we can think of that as the square root of -1 multiplied by the square root of a positive 4. So the benefit of that is square root of -1 is I, square root of 4 is 2, so we can write that as 3 minus 2i. Okay, the number radical 27 doesn't have a nice neat square root, but I can break that down as 9, 3, and then square root of -1. So ultimately, that gives us 3i square root of -1 times a radical 3, which is basically our leftover inside the radical. And so we can write that in the form 0 plus, if we really want to be technical, we could write that as 3 radical 3 I, a plus bi, where your b, your real number, is 3 radical 3. I tend to like my I out front of the radical so it doesn't get sucked underneath, okay, and accidentally become part of a new problem. Today we're going to be focused on basic operations working with complex numbers. So probably the most basic would be to add and subtract. So when you're adding and subtracting, essentially you need to focus on like terms. So if I were going to rewrite this, I notice I have square root of -16, so I'm going to write 2 plus 3i. And I'm just going to deal with that part. Obviously, I could streamline this a little bit. Now, square root of -16, basically at this point, guys, you're thinking of this as 16 times -1 inside. Anytime you have square root of a negative, it's going to give you an I outside of the radical. So I'm going to focus on this as if I didn't have an I. Square root of 16 is 4. And then the square root of the negative is going to give me an I. Okay? So be very careful when dealing with parentheses. Watch your sign. So I'm going to have 2 minus 3i, a -7, and a plus 4i by taking the opposite of each or distributing the negative. Ultimately, by combining like terms, I can combine my real parts to make that -5. I can combine my imaginary parts to make that a positive 1i, or just positive I. And that is my final answer, period. My second example, using the same idea, I don't have the simplification that was necessary on my first one. So another way I could look at this is subtracting is the same thing as adding the opposite of each of these. Okay, so then I can just add those together. -3, and that becomes a positive 6, would be a positive 3. 7i and a -2i would be a positive 5i. A little easier on the work. My next basic operation is multiplying with complex numbers. Now, this is what's going to come up is when I multiply, I'm going to use FOIL or distributive property. You're going to need to understand that there's going to be an I squared that comes up in a lot of these. And since I is defined as square root of -1, I can basically square both sides. And that becomes I squared, and on this side the square and the square root cancel each other more or less. They're inverse operations, and we're left with -1. So I would put that real big in your notes. I squared can always be replaced with -1, which is going to be pretty powerful for us. Now, if I distribute, I'll have 15 plus 12i minus 10i minus 8i squared. Now, I'm going to go ahead and combine these two like terms. I'm going to rewrite this I squared. Excuse me, I lost my square. Be very careful there. I have 15 plus 2i Now I squared, remember, is negative 1. So I can replace that as negative 8 times a negative 1, which is positive 8. So that becomes 15 plus 8, or 23, plus 2i. So there's my form, complex number a plus bi. My second example, I'm going to clean up a little bit first. I'm going to rewrite that square root of negative 1 simply as I. And I'm going to rewrite the square root of a negative 9 as 3i. And then I'm going to distribute just like we did on the previous problem. So I'm going to have 10 minus 15i plus 2i minus 3i squared. Now, if you know I squared is a negative 1, then as a whole, you can think of that term as negative 3 times a negative 1, or positive 3. So I would expect you'd be able to streamline this just a little bit and make that a 13 minus 13i. So far we've added, subtracted, multiplied, so it would make sense we'd need to be able to do division as well. Dividing by a complex number, we cannot just distribute the division nicely because our goal was to get in the form a plus bi, remember, and we have addition in the denominator, and you can't just arbitrarily break that up. So what we have to do is instead use a little algebraic process where our goal is to get rid of that I in the denominator. So what I'm going to do is I'm going to multiply the top and bottom by what's called the conjugate. If we have something of the form a plus bi, the conjugate of that is a minus bi. It's the opposite of the complex, or the imaginary term. So I'm going to take the top and bottom of this by 3 minus 2i. I just changed the sign of the b portion. So 3 minus 2i on the top and bottom, that becomes basically a new problem with distributing. So I'm going to simplify the top. First terms I'd have 6. Outer terms I'd have minus 4i. Inner terms I'd have minus 15i. And the last terms I'd have plus 10i squared. And while I'm at it, I'm going to go ahead and simplify that numerator completely. So 10i squared is 10 times a negative 1, so that's negative 10. So if I combine there, I would have a negative 4 minus 19i. Now, I still have a denominator to deal with. The nice thing when you multiply by a conjugate, when you do your first terms, you get a 9. Outer terms, you have a minus 6i. Inner terms, you'll always get the opposite. So in this case, a plus 6i. And then last terms, I have a minus 4i squared, or negative 4i squared. Okay? Now, with the conjugate, those outer and inner products are going to cancel. I'm left with negative 4 times a negative 1 here, or a positive 4. So I end up with, instead of an I in the denominator, I end up with a nice real number of 13. So I don't have to worry about that, dealing with that complex part. Once I have dealt with that, I can rewrite this by distributing the division, negative 4 thirteenths minus 19 thirteenths I. So that gives you the form a plus bi. Our last example, I've left some negatives underneath radicals, so I'm going to go ahead and deal with that. In the numerator, square root of negative 4, square root of 4 would be 2, square root of the negative would give me an I. In the denominator, I have a negative, square root of negative 9, so the square root of 9 would be 3, square root of the negative 1, or the square root of the negative would give me an I. Now this one's a little unique, is that I don't have the a portion of the a plus bi. Well, if I thought of that as a 0 minus 3i, that lets me know I need to take the top and bottom by the conjugate of the denominator, which is just 0 plus 3i. And you can put the 0 in there if you'd like. I'm going to save myself a little work because I know 0 times anything is going to drop that term out. So ultimately, what that gives me in the numerator, I'm going to distribute and make that 15i plus 6i squared. In the denominator, I simply have a negative 3i times a positive 3i, which is a negative 9i squared. So ultimately, what that gives me, I know 6i squared is 6 times negative 1, or negative 6, plus 15i in the numerator. In the denominator, negative 9i squared is negative 9 times a negative 1, or a positive 9. And then I'm going to distribute that division and make that negative 6 ninths plus 15 ninths I, which is ultimately negative 2/3 plus, divide each top and bottom by 3, I'd have 5/3 I. There's my a plus bi form, complex number form that I'm looking for. Okay, our last experience with complex numbers today is going to be working with quadratic formula and simplifying answers that come out as square roots of negatives. So the first thing I'm going to do here is I'm going to set equal to 0, which is required for for quadratic formula. Once I have that, I'm going to identify my a, my b, and my c. For my quadratic formula, I'm going to have the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times 1, 2 times a, or 2. I'm going to go ahead and simplify a little further. And I will have my negative 3 plus or minus the square root of 9 minus 20, which is square root of negative 11, all over 2a, or 2. Now, since square root of 11 doesn't come out nice and neat, okay, I'm going to think of this as square root of negative 1 times the square root of 11. Square root of negative 1 is I. The square root of 11 doesn't break down at all. If it did, I'd go ahead and do so. So I'm going to think of that part as I radical 11. So it may help some to just think, anytime you have square root of a negative, drop the negative, bring an I out front, and leave whatever underneath the radical, and simplify that radical as much as you can. So my final form, I do want to stay in the form a plus bi, so I'm going to distribute that division and probably technically, if you look in the back of the book, you may find where they take and rewrite this specifically as negative 3 halves plus or minus radical 11 halves I. That gives you your true a plus bi form. I'm not going to worry so much about that, but it doesn't hurt to practice with it.